So we've already talked about some of the exact values. So the exact values, and I'm just going to write these quickly over on the side here just to remind ourselves as well. So pi on 6 is equal to 30 degrees. Okay, so wherever we see 30 degrees, we can change it to pi on 6 or vice versa. Okay, and pi on 4 is equal to 45 degrees, and pi on 3 is equal to 60 degrees. So these are very useful because what they mean is with our exact ratios, we can essentially replace them with our new values. Like that. Okay. So instead of using 45 degrees to get 1 on root 2 for our sine, cos, or tan, we can use our new pi on 4 and pi on 3 and stuff like this. So for example, well, the easiest way to do these is to either, simplify them as much as you possibly can, just in case you've got one which you can't really do, or to convert first and then simplify after, okay? Depending on which one you're easy with. So what I tend to do is I tend to convert first back to degrees and then calculate what they are based on what that is. But it doesn't really matter. So I'll show you both ways, particularly for part A. So part A is cos of pi on 3. Okay. Now pi on 3 is 60 degrees. So this is the same as cos of 60 degrees. And we know cos of 60 degrees is adjacent over hypotenuse in our exact triangle. So cos of 60 degrees is equal to half. Okay. Alternatively, you could just use the fact that pi on 3 is in this corner here. And you could just go straight to a half on 2. Okay, well, 1 on 2, I should say. Okay, part B. Sec of pi on 4. Now we know sec is the same as 1 on cos of pi on 4. Okay. So we need to work out, well, cos of pi on 4. Now pi on 4 we know is 45 degrees. Okay, so 45 degrees is this corner here. Okay. Now cos is adjacent over hypotenuse, so it's 1 on root 2. So this is saying 1 on root 2, which is the same as just root 2. There we go. So 1 divided by 1 on root 2, flip the fraction, times the tops times the bottoms. Part C, sine of 7 on 4. This is 7 pi on 4. So sine of 7 pi on 4. Okay. So sine of 7 pi on 4. Now, sine of 7 pi on 4. So 7 pi on 4, we need to think about it. What is 7 pi on 4? It's a bigger value than what we wanted. So, or what we can work with. So if we think about the top half of the circle, so we've got pi, and 90 degrees on the top makes pi on 2, and it's 0 over here, and that's just pi, and there should be no line under that. Okay, so 7 pi on 4 lies somewhere in this side of, or the second quadrant of the circle. So 7 pi on 4, okay, well, pi on 4 is over here. Pi on 4, it's over there. So it must be bigger than pi on 4. Now 7 pi on 4 is the same as having 7 times pi on 4s. Okay? So let's think about... Oh, sorry, I tell a lie. It's not over in that section, 7 pi on 4, because it's bigger than pi, because 4 pi on 4 is pi. So it's going to be, so if we keep going around, so down here, so we haven't really talked about the exact values too much. So this is our 0 degree, or 0. This is our 90 degrees here. Our 180 degrees over this side, which is not letting me write on. So pi over here is 180 degrees. And down here is 270 degrees. Okay, our 270 degrees is 3 pi on 2. Okay, and so you can just use the multiples of them to work your way around. So if pi on 4 is over here, if we double it, we get pi on 2. And if we double that again, we get 3 pi on 4, which brings us over here. And as you can see, the further and further we go around, the more and more pi's that we add. So 5 pi on 4 goes there, and if we go over to this one, it's going to be where the 7 pi on 4 is here. So that's between 270 and or 360 degrees. Okay. which is also 0 or / 2 pi. Okay, so it's between 270 and 360 degrees. So what we could do is we can convert the 7 pi and 4 back to degrees first, as we said that we could. Or we can use the fact that we know what the exact angles are equal to. So we know that pi, whenever it's on 4, it's going to be an increment of the 45. So 45 or 135, or so 135 on this side. This one's going to be 225 on that side, and this one will be 2 or 315. So we know that sine 7 pi and 4 is the same as sine of 315 degrees. Okay. Now, what we know about sine of 315 degrees is that it's in the 4th quadrant, and using our all stations to Coaldale, we know that only cos is positive in the 4th quadrant. So this is going to be the same as minus sine on, and how many degrees does it take me to get around to there? Well, it only takes me 1 pi and 4 to get there. So this is the same as saying sine on 45 degrees, or minus sine of 45 degrees, which is the same as minus sine of pi on 4. So sine of 7 pi on 4 is the same as minus sine of pi on 4, which is the same as minus sine of 45 degrees. Now, sine of 45 degrees, if we go back to our exact triangles, okay? So sine in this one is our opposite over our hypotenuse, so 1 on root 2. So it's the same as minus 1 on root 2, or if we're going to simplify it, 2 on root 2, minus 2 on root 2. And that's pretty much it. Okay, so nothing too tricky there. Okay, so it's just going back to your exact values and trying to remember what your exact values are. Now, sec of 7 pi on 6. So 7 pi on 6 is a little bit harder. I'm going to draw a circle again to just convey my point. Here's our thing-o, our good old thing-o, our unit circle. And on this unit circle, what we're going to do is we're going to look at all the different parts. Apparently that's the maximum. So, as we said, our pi on 4 splits up that way. But our pi on 6, which is our 60 degrees, and our pi on 3, which is our 30 degrees, goes there. So if we jump around by pi on 3s, so essentially we're breaking our circle into thirds. So it should be 0 to 30, 30 to 60, which is our pi on... Oh, sorry, pi on 6. I went around the wrong way. Oopsies. So to there is pi on 6, pi on 3. Okay, and then to here gives us our 90 degrees. So jumping around by pi on 6s, I should say, can potentially get us to our value. So in this case, we want to get to 7 pi on 6. So pi on 3 is the same as 2 pi on 6, for example. Pi on 2 is the same as 3 pi on 6. Okay, so jumping around another 30 degrees, so that gets us to 120, would be 4 pi on 6. And you can kind of see the picture here, but jumping around all of these pi's on 6s is going to get us our value. So we want to get to 7 pi on 6, so it's one more jump in this direction, so 7 pi on 6. Okay, so that's here. So 30 degrees more, because remember, we're jumping around by 30 degrees. So 30, 30, so ignore that one. So it's 30 here, 30 here, 30 here. And remember, you're going 30, 30, 30. And then you got your 30 in this one here too. So adding all those 30s up, you get 30, 60, 90, 180, 210. So our original one of sec, so sec of 7 pi on 6 is the same as sec of 210 degrees. Now remember, if you find doing these exact values with the circle too hard, you can always just convert it, okay? So remember, if too hard, convert. So 7 pi on 6 times by 180 on pi. Okay, the pi's cancel out. Okay, 180 divided by 6 is equal to 30. So this just becomes 7 times 30, which is equal to 210. Okay, so sec of 210. So you can just make that simple conversion if you want to, and it works as well. So sec of 210, so sec, as we decided, was 1 over cos of 210 degrees. Now we need to work out, well, what's that as the exact value? Or what's that in terms of the unit circle? So all stations to Coaldale or Central or Cardiff or wherever you are in the world. So tan's the only one that's positive in the third one. So this is the same as -1 on cos of 30 degrees because we're 30 more than 180. So cos of 30 degrees coming back up to here. So 30 degrees. So cos of 30. So 30 is up here. So it's adjacent over hypotenuse, which is that one there. So root 3 over 2. So this is the same as -1 on the square root of 3 over 2. Okay, which is the same as -2 on root 3. Or -2 root 3 on 3. And there we go. So that's some simple conversions of those ones there. Now, we're not always going to have values like that. Sometimes we're going to have some trickier ones, like these ones here where it's just flat out values, but you can just use your calculator for those ones. So sine of 1, for example. So make sure your calculator is in radian mode by hitting shift and mode and then pressing 4 for rad. So then we're going to start off by sine of 1. So you can literally just put these ones in and it'll tell you how much radians it is. So a sine, whoa, what happened there? Sine of 1 is equal to 0.8414, and that is for our 4 decimal places. And b, cot of 1.7 is equal to, now remember cot is the reciprocal of tan. I've been saying inverse, but it's meant to be reciprocal. So the reciprocal of tan. So 1 over that, and we can just put that one straight into our calculator. So 1 over tan of 1.7. Close it off and we get -0.1299, just like that. Okay, so that's it for the radians. What we're going to do next is going to solve some trigonometric stuff, and then we're going to use some arc length and sectors in a bit. So with that being said, I'll talk to you guys in the next video.